Now, the same sort of properties that you can use, the same sort of process that you would use on a problem like this green one over here. In the last video, I explained kind of how to divide numbers by hand. We can take a similar approach and divide a polynomial like we have right here. So we're dividing two polynomials. Now, this first problem is actually one that you can answer without using my new process that I'm about to show you. But I want to start with this so you can see that you get the same results. Remember, we did talk about dividing polynomials, where if you can do the magic numbers and actually factor the polynomials, for example, I'm not going to go through and actually do the magic number process here, but this guy's going to turn into x plus 2 times x plus 3 over x plus 2, just like this, if you actually factor it. And if you recall, since we have matching pieces right there being multiplied matching factors, we are allowed to cancel those out. My final answer to this problem should be x plus 3, and it is. So, as you recall, earlier on in the year, I did say, like, wow, it was kind of great. Like, every problem we did, it seems like they magically canceled. Now, that's not always going to be the case. So we need a new process. Well, what happens if it didn't factor, or if nothing matched when we did? We would have been out of luck beforehand, but now I'm going to show you a process for doing this. So I'll leave this work up here so you can see what the answer is actually supposed to be. But I'm going to go ahead and do the same sort of thing. The number on the bottom over here on the right, we had a 9 down there, went on the outside of my division box. So I'm going to put my x plus 2 on the outside, and the top part goes on the inside. So I have x squared plus 5x plus 6. Now, the first thing we did is we took our number on the outside, that 9, and we saw how many times it went into the first thing we could on the inside. So we basically want to take a look at this, and when you're doing these problems, you're going to look specifically at the leading, like the highest degree, the variable with the highest degree that we see. So I want to look at that x right there. You have to ask yourself, how many times does x go into x squared? Or another way of thinking about it that might be easier on you, x times what number gets me to x squared? Well, if you think about it for a little bit, x times x equals x squared. So I'm going to put an x up there up top. And when I do this, I'm actually going to multiply that x against this guy right here. After we put that 3 up top in my other problem, I'll do that over here in blue. We did 3 times 9 and got 27. That's how we got that number down there. So we're going to do our x times that number right there and put it below. So I'll erase those lines. Let's see. When I do that, x times x, I get an x squared. That comes from this part right here, x times x. I also do x times a positive 2, which gets me a plus 2x. Now, once I get that in place, the next step was to subtract. We did 30 on the right, going back and forth between left and right side right here. But over here, I did 30 minus 27, and I got 3. Then I brought down my next number. So I need to subtract these two polynomials right here. A little minus sign over on the right side. And when I subtract this, x squared minus x squared cancels out. That's great. It goes away. 5x minus positive 2x is 3x. And just like in the last problem, after we check that, we're going to bring down our next number. So I bring down my plus 6. We're going to do the process again. X times what makes a 3x? Or x goes into 3x how many times? Positive 3. So I'm going to put a plus 3 up here. Now if I take my 3, I have to multiply it against both parts. So I do 3 times x, which is 3x. And I do my 3 times positive 2, which is plus 6. If I subtract them, 3x minus 3x goes away, 6 minus 6 goes away, I get no remainder. So it does go in even. And you'll see my answer's kind of got some yellow on it right now. But the final answer that you do get up here is x plus 3. Same thing you got if you do it with the factor. So let's look at another example. And you might be inclined to say, well, I understand magic numbers, I understand the factoring, why do I need to do this process? You can imagine, though, that a lot of things, it's just not going to match up. The factoring process doesn't always work, because there's no guarantee it's always going to cancel. So I'm going to set this one up the same way. I'm going to put my x minus 4 on the outside, and my guy right here, we have 2x squared plus 7x minus 10. And we're going to do the same process. Got to see how many times x times what gets me a 2x squared. Well, x times 2x is 2x squared. So I'm going to put that up here. Multiply it in. 2x times x is 2x squared. 2x times negative 4 is going to be minus 8x. And when I subtract these, the toughest part about this process, and the place you will probably mess up most, is dealing with negative signs. You have to be very careful when you subtract these two things. 2x squared minus 2x squared is fine. That goes away just like always. For this next part, though, I have to do 7x minus negative 8x. We have positive 7x minus negative 8x. When you subtract a negative, you're really adding. So that's really saying the same thing as 7x plus 8x, which is 15x. Very commonplace for mistakes right there. A lot of people would say like negative 1x in that situation. Once you get that in place, though, you're going to do the same sort of deal. You're going to look and see x times what. Oh, sorry, before we do that, we're going to bring down our next number. So we bring down our negative 10. Forget about that step. Now we say x times what makes a 15x. Well, x times positive 15 does. So 15 times x makes a 15x. 15 times negative 4, again, we're multiplying the 15 against both parts here. 15 times negative 4 makes a negative 60. When you subtract again, x's cancel. Negative 10 minus negative 60 is going to be a positive 50. Now in this problem, we have a remainder. That didn't happen on the last one. Last one just went and even if we got a 0 there, we were done. If you remember what I had you do with the original problem, back in the first video with dividing plain old numbers, like on the left side right here, we looked at the remainder. We got a remainder of 4 when we did that problem. And we took that remainder over the number we divided by. The picture's kind of a mess there, but we did 4, the remainder, over what we divided by in the first place, that 9. And that's what went over here on the ends. So what I'm going to do right here for my remainder, I'm going to take this guy, the 50, my remainder, and I'm going to put it over the thing I divided by in the first place, which was x minus 4. And you're going to always want to add your remainder on. So it's always just plus remainder. So you take the remainder over the number you divided by, add that on the end. This whole thing is my final answer. When I divide these, I get 2x plus 15 plus 50 over x minus 4. And I'm not going to show it in this video, but if you do multiply, like you do FOIL with x minus 4, and then the thing we got circled in yellow here, you will get back to your original answer. So I have one more example for this video, and what I did on this one actually, this is the problem up here written on the board. If you're feeling good about this, I want you to actually go ahead and pause the video after I'm going to show you the answer under this blue box here. So if you want to write down the problem and not look at it, you can pause it now. But I'm going to show the answer, and then I'm going to work through it. So if you manage to get the answer based on just the ones you've seen before, awesome, you're good to go on this video. But I am going to reveal the answer right now. Let's see if I can delete this guy in the meantime. So there's the answer to the problem, and I will work through it and talk my way through it so you guys can see one more example fully done. But if you already got the answer, you got it correct, you are good to go. And if you still would like to try the problem, you can still pause the video. And that's probably a good idea. Pause the video, try it out, and then later on you can watch the video after you get your answer, see how it's actually done. But I'm going to go a lot faster through this one. X goes into 3x squared, 3x times. X times 3x makes 3x squared. If you actually multiply that 3x, then you get 3x squared, 3x times x, plus 18x. If you subtract, these cancel. Negative 4 minus 18, positive 18, is negative 22. Negative 22x. We bring down our next number. X times negative 22 makes negative 22x. We multiply it in. We get negative 22x, and that's negative 22 times 6 is going to be a negative 132. Believe. Yeah, that's right. Okay, so we subtract those. 20 minus negative 132 is going to be 152, which is our remainder, which we ran out of things to bring down. So all I'm going to do is take my 152 right there, put it over the thing I divided by, and add that on the ends, and there's my answer. The purple is what you get when you divide the original black problem. And you see it does match the part in